Hello everyone, I'm Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Sorry for my voice. So I request everyone, please pause this video and try this question by yourself, and please write your answer in the comment box, whatever answer you get. Okay, so I believe you have tried, so let's start. Now question, what is the correct order of acidity? So three compounds are given. Actually it's a OME, phenyl methyl ether, and this is a CH3 attached directly to benzene ring. So it is actually a disubstituted. And if you look at their position, this is ortho 1 2, this is meta or 1 3, and this is para or 1 4 orientation. So what is the correct order of acidity asked here? Now remember, whenever the question of acidity asked to you, blindly you should go to the concept, that is the stability of conjugate base. Now what is the logic? Logic is that if stability of conjugate base is higher, then acidity will be higher. Means more the stability of conjugate base, more is the acidity. Now what is conjugate base? So if you remove proton from this molecule, whatever negatively charged species remaining, that is the conjugate base. So here proton release will happen from here, here and here to produce these three conjugate bases. Now you may ask one question, that sir, there are protons in the aromatic ring or protons present in this OCH3 group, why you are not removing proton from here? Remember, the proton removed part from here is relatively more stable, as the position here is called benzylic position, and whatever reactive intermediates like carbocation, carbanion or radical produced at this benzylic position, it is resonance stabilized. Okay, so that resonance stability is not available in case of this proton. I mean, you can say this is a phenyl proton or sp2 proton, or these proton sp3 proton. Okay, so this benzylic proton which are sp3 in nature, after removal of proton, this carbanion is in conjugation with the benzene ring or in the pi electron cloud. This is we understand. Now that's why every case these negative charge is generated on the benzylic position. Now the stability of the conjugate base will be decided upon the position of this OMe group. Now let's look at this OMe group. Have two kinds of effect. One is plus R effect, means you can expect these lone pairs of electrons are delocalized into this benzene nucleus. This is plus R effect. And another kind of effect operating here, that we call as minus I effect. Means if you look at the oxygen carbon single bond or sigma bond, oxygen is more electronegative with respect to carbon. So consequently the polarization of this sigma bond will be carbon to oxygen, means oxygen will be delta negative, carbon will be delta positive. Means oxygen will pull some amount of electron density from this bond because of its higher electronegativity. So that is designated as minus I, which operates through the sigma bond, and plus I, which operates through the pi network. So this is the difference. And for this phenolic ether or phenol system, plus R is dominant over minus I. Now in this case what I produce all are electron rich, I mean conjugate base are electron rich molecule. So who can stabilize these conjugate base molecules? Obviously electron withdrawing group or electron withdrawing effect. Now if you look at plus R effect, it is an electron donating effect, and if you look at minus I, it is electron withdrawing effect. Now minus I will help to stabilize and plus R will help to destabilize this carbanion. Now if you look at this one, 1 to ortho case, so in this case we know this OMe shows its plus R effect at ortho position with respect to this OMe group, means it will increase the electron density into ortho position and para position. So this is actually a destabilizing factor here, plus R. Why? Because here negative charge, extra electron density, because of the resonance extra electron density comes at here. So will the benzene ring be that much capable to delocalize this negative charge efficiently? Answer is no. So this is the negative factor. So that's why it is not that much stable, this conjugate base, and in this case obviously the stabilizing factor is minus I effect. and it is closer 1-2 relation. Now if you look at this one, meta one, so in this case the plus R effect because of this OMe group will work here. So you can see these plus R effect not directly attached to this carbon which is attached to CH2 minus. So in this case the electron delocalization inside this benzene ring will not be that much hampered. So here plus R effect is absent, destabilizing factor, and stabilizing factor minus I exists, but you can say it exists weakly. So I can say there is a moderate stabilization factor. So this is a positive part. Now if you look at the third option here, this OMe shows plus R effect, means these two ortho positions have extra electron density and even para position. So similar destabilization effect like this is also present in here. So plus R active, and if you look at minus I is actually very weak or negligible. Remember one statement, minus I effect is dominant or more efficient in close proximity like this one, but far you go away minus I effect became negligible. So this is the overall concept, student. Now if you look at this, now what will be the order? So from there what you understand, that destabilizing factor is absent for this B option and weakly stabilizing factor present. But if you look at here, destabilizing factor for this 1, 2 means ortho or para, both are present. So from there I can say B will be maximum acidic because the conjugate base is relatively maximum stable. By the way, I am talking maximum acidic means among 3. So this is B is the maximum acidic. Second position will go to obviously option A. Why? Because in this case stabilizing factor minus I also works. But if you look at stabilizing factor in case of this para isomer is negligible. So compared to para, ortho is more stable. So B greater than A, and obviously the last option remains C. So this is the order for the acidity. So B, A, C. So option C is the right answer. Now if you get this question in your exam hall, how can you solve it less than 30 seconds? For that purpose, look at here. OMe's plus R effect operate this 3 position, so which hinders the stabilization of the conjugate base, and obviously weakly active minus I works here. So I know it's a confusing question, but I believe you should remember this information. And remember, in case of OMe group, plus R effect works in both ortho para, but minus I works on ortho position only. Effectively, I am meaning. So B greater than A greater than C, you need to think. Now if you still get confused, sir, I am not efficient in that much also, how can I solve? Possible? Yes. So from this you understand that orthopara position of this OMe destabilizes the resonance or delocalization of the negative charge. So B will be maximum acidic. So if you think that option A gone, option B gone, this is called process of elimination, very helpful solving MCQs. Now next position, between A and C, who will be more acidic? Obviously minus I is closer to this methyl, option C. Okay, so this is, in this way also you can solve this question. Now I have already uploaded a dedicated lecture about acidity of benzene versus toluene. Why I am giving you this? So such that if you have any doubt regarding this statement, that sir, why not this proton, is why benzene proton, sp2 proton is less acidic compared to this benzylic proton, I mean toluene proton. If you have doubt or if you want to learn about this, please visit this video, it will help you. Now this is the overall discussion. I thanks everyone for watching, and if you have any doubt regarding the logo of my channel, I request you please read this part. So see you in my next video. Bye bye.